Hey everyone, this is the video for lesson 9.1. It's on solving quadratic equations. This chapter is almost all on quadratics, and a quadratic is just a parabola. So you know x squared, you've seen those, you know how to translate them and reflect them and stretch and shrink them. Now we're just going to do a whole bunch of different things on quadratics. Most people find this chapter to be the hardest chapter in this class, just because it's a lot of things you have to remember. So there are 7 sections. Each one teaches you a new way to look at quadratics, and it is a lot to remember come the test. All right, so first, a baseball batter pops a ball straight up. The ball reaches a height of 68 feet before falling back down. Roughly 4 seconds after it is hit, the ball bounces off home plate. Sorry if you can hear my cat. Sketch a graph that models the ball's height in feet during its flight time in seconds. All right, so something like this is going to be a parabola, because that's the point of this chapter. It's going to be upside down. So it's like it's been reflected just because it went up in the air and then back down. So if you can imagine like a ball's like trajectory after it's been hit, it goes up and then back down. So it kind of looks like a parabola. So it's going to look something like this. So notice that it doesn't start at 0. It starts at about 5. That's assuming that, so someone's holding a bat, right? And they swing. They're assuming that the path of their bat is 5 feet in the air. So that's when the ball gets hit, when it's 5 feet in the air. Then it goes all the way up to 68 and it goes all the way back down and it hits at about 4 seconds. So all these things are given to you except for the height of the batter. Make sure you label, so height of a ball, this is time, this is height in feet. So when is the ball 68 feet high? Now that happens around the halfway mark. So if it takes the ball 4 seconds to hit the ground, its highest point is going to be at about 2, so that's halfway. How many times will the ball be 20 feet high? So look at this graph. This is 20 feet. If you drew a horizontal line, you could see that you hit this parabola twice. You hit it here, and you hit it here. So it's twice, on the way up and then on the way back down. All right. So this thing, it's called projectile motion. We're going to do an example or like a whole investigation in class. So I got nothing for you here just because it's way too involved to do in a video. So be ready for it. Make sure you have a calculator that has batteries and is charged or is charged right when class starts tomorrow. All right, we are using general form. They kind of throw this in this chapter, so I'm just giving you the definition. So this, if you have a quadratic, so notice how this has a square, so that immediately makes a parabola, but now you have like these other things added onto it, which you've never seen, but you're going to get really well acquainted with all types of quadratic equations. So this is general form. You're going to see 2 other forms by the end of this chapter. We're going to solve this symbolically. Symbolically, if you don't remember, is just on paper. So just do it out. Solve like you normally would. So we have this. I want to get this chunk by itself so I can take the square root. So there's a whole bunch of stuff in the way. First, you have this 10. So I'm going to add 10 to both sides. Then the 5 is in the way. So I'm going to divide both sides by 5. Now I want to take the square root. But notice this side is not really square root worthy. So look at what I do. If it is not square root worthy and it doesn't ask for an approximation, so if it asks for an exact answer, or on the side I want you to write here, a radical, R-A-D-I-C-A-L, radical answer means you're going to leave it in a square root. And we have a plus minus out front because when you take the square root of something, you have the positive answer and you have the negative. Okay? So that's how you would leave this. If this number was 36 or if it was 64 or 100, then you would take the square root of it because you can. But you can't take the square root of 11.4. It's going to be some ugly decimal. So we leave it like this. We leave it in radical form. Now I still have to solve for x. I'm not done yet, so I have to bring the minus 2 to the other side. Notice that I put the minus 2 out front. The reason why I do that is because if I put it back here, you might accidentally extend your square root a little bit too much and it looks like the minus 2 is underneath it. The minus 2 has to be on the outside. So your answers are, you have 2 here. You have negative 2 plus the square root of 11.4. You also have negative 2 minus the square root of 11.4. So remember in chapter 7 when you were solving these things, you always had 2 answers. Remember we would split the problem, one positive, one negative, and we'd finish. So same thing here. You're still going to have 2 answers so long as it's a parabola. All right, so last part, it's on the different types of numbers. So right now we have just the real numbers. So there are not real numbers. They're called imaginary or complex. You'll see those in Algebra 2. So we're working with reals, which are numbers that you see normally when you do math. There are 5 different types of numbers. So you got 1, 2, 3, 4, 5. So we're going to start with the innermost one. So this one is the smallest subset of the real numbers. So natural are your counting numbers. So you start with 1 and you keep going. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on to infinity. Cannot have a decimal, cannot be negative, cannot be 0. Whole is the natural numbers with 0. So you start with 0 instead of 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, on to infinity. Still cannot have any decimals, still cannot be negative. Integer means you can go backwards, so you can go into the negatives. So you can go all the way to negative infinity, all the way up to positive infinity, but you still can't have any decimals. So notice how my subset's getting bigger and bigger each time. This one, 1 through infinity. This one, very slightly bigger, just slightly bigger because you add just 0. But this one, we like doubled the size of the subset because we're going back to the negatives now too. Rational are fractions, terminating decimals, or repeating. So if you had 2.33333333, that would be a rational. So numbers can be multiple things. So I'm going to stop at rational for now. I'll go into irrational in a second. But if you have something that is a rational number, it is also an integer, a whole, and a natural. So if I say, what type of number is negative 5/2, it is everything. Oh no, I'm doing that backwards. I'm sorry. If you start on the inside, it's also everything on the outside. So if I say the number 7, that is a natural number, that is a whole number, that is an integer, and it is a rational number. And it's also real. Everything's real. Okay, so you can work, if you're on the inside, you can work your way out. So if I start with negative 4, so if I start in the integer bubble, it's also rational and real. Okay, if I started with negative 5/2, it would just be rational and real. I can only work my way out of the bubbles. So rational negatives are allowed. I didn't click on that. Okay, irrational numbers, they cannot be made into a fraction. Their decimal doesn't repeat or terminate. So right here, square root of 7. That's like, what is it, 2.6-ish? 2.6 something. And it goes on forever, but it never repeats. It never terminates. Pi, 3.141592.6, blah, 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 blah. Doesn't repeat, doesn't terminate. That's irrational. 3 plus the square root of 5. Square root of 5 is an ugly decimal, so it doesn't matter if you add 3 to it, because this makes it irrational. Irrational is also real. All of these types of numbers are real. All right. So this is the last slide. I don't have a tic-tac-toe because we are going to spend that time doing that investigation that I was talking about, the projectile motion, and then I'll give you like a couple problems after. All right. So make sure your marking is done because you're still going to have a quiz. Taking good notes, and make sure you have your calculator ready to go in class, and have a good night.